have your attention, please? I promise to go over this from top to bottom because these are the questions that are going to be your free response on your exam, okay? So, Isaiah, move your chair, honey. Thank you. All right, so this is section 9.1, graphing asymptotes. Tonight's homework is page 575. You guys are going to do numbers 1 through 14. The homework is very, very, very simple compared to what we're going to be doing in class. We're going to do the hard stuff together so that you can ask any questions that you need. So by the time you get to the homework, you're like, that's it. That's the point of today, tomorrow, and Thursday and Wednesday. Okay? Thursday we're going to be reviewing. So don't just kind of go through the motions with me. I need you guys to ask questions if I lose you. All right? Let's go ahead and go over number 1 from the warm-up. We have f of x is equal to x cubed plus 3x squared plus 2x over negative 3x squared minus 12x. What I'm going to recommend is that you create some compartments, if you will, or shelves, so that you don't just have like a glob of work everywhere. Okay? So what I'm going to recommend is you make space that's delineated for all 4 parts of the things that we're going to be doing. So the first thing that we want to do is find some asymptotes. So let's call this our vertical asymptotes. Let's find our vertical asymptotes here. The vertical asymptotes are found by setting the denominator equal to 0. So I highlighted the denominator because I'm going to set the denominator equal to 0. I'm waiting for you guys to take your highlighters out, please. I'm going to be expected to do this without a graphing calculator. So I want to do as much as I can manually and only check it on the graphing calculator when I'm done. So I need to be really, really, really masterful with my scientific calculator. Isaiah, don't let me lose you, babe. So the scientific calculator I need to know how to use just as well as the graphing calculator, okay? Vertical asymptotes mean I'm going to set the denominator equal to 0. Sophia, what can I factor out of negative 3x squared minus 12x? Yep, I can take out a negative 3x. So that means I'm going to divide both of those by negative 3x, and I'm left with an x plus 4 equaling 0. So I just do the 0 product property. So that means I'm going to say negative 3x is equal to 0, and I'm going to say x plus 4 is equal to 0. So that means here x equals 0 and x equals negative 4. Those are my 2 vertical asymptotes. On Friday, we went over horizontal asymptotes. Destiny, when you watch the video, it's going to make this very easy. Right now, it's going to seem complicated, but I need you to watch the video, okay? Horizontal. Sean, how do you know if something has an horizontal asymptote? Remember what we did on Friday? Oh, you weren't? Oh, that's right. So you got to watch the video too, babe. We got to see if it's top heavy or bottom heavy. What is it, Macau? Top or bottom heavy? Top heavy? How did you know that? Tell Sean how you knew it was top heavy. But say it louder so Destiny can hear too. As a higher exponent, right? So there's a higher exponent on top, so that means it's top heavy. And Samantha, if you're top heavy, do you have a horizontal asymptote? There is none. That was good. Whew. No work there. That's good to know. Okay? All right, Kyle, we also went over x-intercepts. And the way you find the x-intercepts is by setting the numerator equal to 0. So highlight that. And this time we're going to set our numerator equal to 0. Daisy, what can I factor out of an x cubed, a 3x squared, and a 2x? Daisy? Yep. Take out an x, and I'm left with x squared plus 3x plus 2. And now I can factor this. What factors x squared plus 3x plus 2? X plus 2 and x plus 1. I'm going to do the same thing I did up here. I'm going to do the zero product property. Isaiah, am I going too fast, babe? Okay, I'll try to slow down, but can you try to catch up? Meet me halfway. Yeah. All right, so I'm going to set each of these equal to 0. So x equals 0, x equals -2, x equals -1. And these are my x-intercepts. That means that it passes the x-axis at 0, 0, at -2, 0, and at -1, 0. So look, I've got 3 points right there. Dylan, I don't feel like I answered your question thoroughly. Ready? If you set them both equal to 0, and it's the same exact number, then yes, it's the same exact whole. All right, the easiest way to tell if it's a whole is if something cancels in the numerator and the denominator, right? I have a question for you. Wasn't this all the stuff in the denominator? Say yes or no. Yeah. Wasn't this all the stuff in the numerator? Don't I have a 0 and a 0 both in the numerator and the denominator? So aren't they going to cancel if one is in the numerator and one's in the denominator? So where do I have a whole? At 0, 0. You see it? You have a whole at x equals 0, okay? So the best way to tell, which is why I put these on top of each other, is if you have an intercept that is contained in both of these boxes, then it's going to be a whole. So there's a whole at x equals 0. God bless you. All right. The last part is for you to plot points. And we're going to be very smart about which points to plot. We're going to use our asymptotes here, and we're going to use 3 numbers to the left and 3 numbers to the right, just like what you guys did in the homework. Okay? So here's my 3 numbers. Here's the first asymptote. Or actually, the first one's -4, excuse me. Then I'm going to do 3 numbers. Then I'm going to do the next asymptote, and then I'm going to do 3 numbers. And that should be enough. So the 3 numbers before -4 are -5, -6, and -7. This will be -3, -2, -1. There's 0, 1, 2, and 3. This is the fun part. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers, 4 of you in a group, split it up. Who else did -7? I did. Did you get -210? Yeah. Wait, why are we getting so many different answers? I got 10 thirds? Did you plug in -7? Who else did -7? Should have been 1 person per group. What'd you get, Ben? So I got, half of you got -210, and the other half got 10 thirds. Is there anybody else who got something different? So this is how the graph is going to help us, because once you do other numbers, you're going to see, is 210 ridiculous, or is 10 thirds ridiculous? okay? Because your answers are going to lean towards the asymptotes. Remember how our graphs are always going to lean? Oh, you're not convinced. Watch, let me show you what I mean. What about those of you who plugged in 0, what should you have gotten? Undefined. Why? What did we find out about x equals 0? It's a whole. It's not 0. It's a whole. Okay? It's a whole. But where is the whole is what I need to find. So watch. Where is the whole? That means where did the graph have the audacity to pass the x equals 0? Did it pass it up here, down here, in the middle? We got to figure out where it passed it. Everybody with me? You guys are not with me. Ready? There's this asymptote, right? It's an electric fence, remember? You're not allowed to pass it. But this graph had the audacity to pass it. This is x equals 0. But we don't know if it passed it here, here, here. We don't know where it passed it. You guys with me? So we have to see where it passed it on the x equals 0 by plugging in 0. Everybody with me? So what happens when you plug in 0 here? 0, and then 0, and then 0, and then 0, and then 0, right? That's why you don't plug it into the original, because duh, you're going to get undefined. Hello, we already know it's a whole. Isaiah, oh my God, if you don't listen to this, you're going to be so lost, babe. You're going to be like so lost. So what you have to do is you have to plug it in to the equation after you've taken out the whole. So in other words, in the numerator, didn't the negative 3x create the whole? What's left over? X plus 4, so you're just going to put an x plus 4 up here. And then what was left over when you took out this whole right here? This right here, right? So this is what's left over on the bottom, x plus 2 and x plus 1. This is where you plug in the 0. Okay, ready? Plug in 0 here. What do you get on top? What's 0 plus 4? 4. What's 0 plus 2? 2. 0 plus 1? 1. What's 2 times 1? Okay, so where's the whole at? Oh, I think I wrote this wrong. Oh, no, it's right. Roughly at 2. All right, here we go. All right, here we go. Ready? Now we want to plot these points. What happens when you plug in a -1? You get a 0. What happens when you plugged in -2? You got a 0. So it hits it at 1, -1, pretty much at -1 and -2. What about 1, 2, and 3? What'd you guys get here? What'd you guys get for 1? What'd you guys get for 1? Destiny, what did your group get when they plugged in 1? All right, let me give you guys some more time. Plug these in, guys. Come on, this is like all calculator work. Plug it into the calculator. Yeah, babe. You guys use synthetic division if you're not plugging it in right. Paige, is it locked? Can you unlock it for me? You guys check with each other because this seems to be the place that you guys are struggling the most, is just plugging in points. Can you please help each other out? Hey. x cubed plus 3x squared plus 2x over negative 3x squared minus 12x. I could plug it into that, or I can plug it into what I factored. If I prefer, I can plug it into x times x plus 2 times x plus 1 over. I'm going to plug it into factored form. Isaiah, don't let me lose you. Please. Plug in 2 here. Instead of x, you're going to plug in 2 times 2 plus 2, which is 4, times 2 plus 1, which is 3, over negative 3 times 2, which is negative 6, and then 2 plus 4, which is 6. Stop staring at the door. Sorry, Jules. Just don't want them staring at the door when somebody walks in. Here we go. 2 times 4 times 3, that's 8 times 3, that's 24, over negative 36. Both of these can be divisible by 12, so that's 2 over 3 negative. Who got that? Very good. So you should have negative 2/3 when you plug in 2. Thanks, babe. Put it right here. All right, pretend it's a test question. Plug in 3 by yourself. Do it. Plug in 3 and see what you get. We found out that this right here, negative 4, we saw it's an asymptote, so it's undefined. Kyle, what about letter C? What'd you guys get for negative 5? Just 4? Everybody get that? I like whole numbers. They're my friends. How about letter D? 3 1/3. Positive, right? So you guys remember some of you guys who plugged in negative 7, then you got negative 210? I don't know. I don't know if this is going to be negative 210. Okay. Last thing we have to do is graph it. So now that we have our 4 sections, we know exactly what we're going to graph. So I'm going to do it on a large piece of graph paper so that you can see. My expectation is that you turn the page and don't try to squinch it in some little corner in your graph. This is the most important part of your work. Let's go through this quickly, please, because I still need to give you one small part for tonight's homework and then we're done. We have an asymptote at x equals negative 4. Here we go. Watch how fast you do this, you guys. Watch. 1, 2, 3, 4. Asymptote. Draw the asymptote. Then you know that the hole, there's no asymptote at 0 anymore because there was a hole. So you know that it passed the x-axis at negative 1 and negative 2. And then we found that it passed the hole at negative 2. We said 2, but the reason why I said about 2 is because we forgot that there was a negative sign at the bottom. So we know there's a hole right there. Everybody with me? And then let's plot these points right here. You guys told me this was undefined. Negative 5 was up at 4. Negative 5 was up at 4. Negative 6 was 3 1/3. So negative 6, 1, 2, 3, like that, like a little bit over 3. I really highly doubt that negative 7 is 210, whoever got that. So this part of the graph is leaning towards the graph, so it does this. And this is leaning towards this, like that. Mr. Riad, how'd you know? The graph is always leaning towards an asymptote. Okay? What did you guys get when you plugged in -1, -2, -3? You got -2/3. That's how I know it didn't do this. It's -2/3, which is down here. Everybody with me? Because some of you guys are like, Miss Riad, how come you didn't lean it this way against this side? Well, when I plug in -3, it's not even up here. It's down here. So you know it's leaning this way. Everybody see that? That was all one problem. I'll give it to you. It's very meticulous. There's tons of parts. Gerson. Really? There's tons of parts to it. But it's hard if you don't take the time to make the compartments for each part that you need. Some of you guys are trying to make a full course meal in one kitchen and not make designated areas. You're trying to make the steak and the cake and the bread and everything on the same countertop. And you're expecting for everything to taste good. And it's going to be yucky crap. You have to do one thing at a time to make sure that you guys get each part that you need. All right. The second one I'm going to have you check on your own. I need you guys to copy this down because it's for tonight's homework. The definition of a rational function and what it is and what it is not. Turn off the lights for me, please. Just copy this down. Definition of a rational function is when you can write anything as a fraction. So this right here is not a fraction. This has an exponent as a variable here. So it's a fraction to an exponent. So anytime the exponent is a variable, it's not a rational function. This is also not the rational function because the definition of a rational function, it can be written as the ratio of two polynomials. This is not a polynomial. And these are all examples of possible rational functions. On tonight's homework, the first part, you just have to identify, yes, this is rational, no, this is not. Second part of the homework, is you have to identify asymptotes from a graph. So easy compared to what we just did. All you gotta do is look at the graph and be like, oh, there's an asymptote at x equals 4. And then you put the answer, x equals 4. So compared to what we did in class, tonight's homework is a breeze. And that's how I want it. I want the homework to feel easy compared to what you have to do with me. Yes, sir.